study guide for Chapter 7 test. Again, remember there's a homework that looks like the study guide, and the test looks like the homework, which looks like the study guide. So this should be a good review for the test. It says write each ratio in simplest form. Remember, in a ratio, we said in this text it's a comparison of two items. As we went back to the Algebra 1 text on page 51, we said whatever it says first goes first. It said AB first, so we put AB first. So AB is 14. BC was second. BC is 8. Also on page 51 of the algebra text, we said whatever it says first goes first. We said a ratio has to be whole number to whole number. You cannot have a decimal in a ratio, and we learned how to fix that. And then all ratios must be reduced by dividing each member of the ratio by their greatest common factor. The greatest common factor between 14 and 8 would be 2, so that would reduce to 7 to 4. Any questions on number 1? Number 2, angle A to angle B to angle C. We see that both pairs of opposite sides are equal here. That's one of the ways to prove that a quadrilateral is a parallelogram. So since we know both pairs of opposite sides are equal, we can say it's a parallelogram. In a parallelogram, both pairs of opposite sides are equal. Both pairs of opposite angles are equal. The diagonals bisect each other. Each diagonal forms a pair of congruent triangles. Consecutive angles are supplementary. So you got all these properties. Using all of that, one of those was both pairs of opposite angles are equal, so we got that. So we can say angle A is 100 degrees. Angle B is 80 degrees. Angle C is 100 degrees. We're going to simplify by dividing by their greatest common factor, 20, and we would get 5, 2, 4, 2, 5. You can't reduce the 5s on down because what you reduce an extended ratio by has to go into all three, not just 2 out of 3. Angle B and C, angle B is 80, angle C is 100. You would again divide by the greatest common factor, 20, and you'd get 4 to 5. AD is 8. It goes to BC, 8. Then it goes to AB, 14. We divide by the greatest common factor, 2, and we'll get 4, 2, 4, 2, 7. Again, you can't just reduce the 4s. You would have to have something that goes into the 4s and the 7. Any questions on the first section? Writing ratios in simplest form. All right, the next section is dealing with proportionality. To solve a proportion, we can cross multiply. You could make equivalent fractions also. If you cross multiply, you're going to have 24 times x is 24x is equal to 6 times 20 is 120. You would then divide both sides by 24, and you get x equal 5. Likewise here, we could just make equivalent fractions. We could go backwards, right? 24 divided by what is 12, 2. So 144 divided by 2 is 72. Make equivalent fractions rather than cross multiply. Okay. The 7, 8, and 9 are looking at properties of proportions. When you go from here to here, what we did is we put bottom over top. So we would put bottom here over top here, B over A. When we go from the if to the then, we had top P plus bottom Q over bottom Q, so top plus bottom over bottom. So we'd have top plus to plus bottom. over bottom, top plus bottom over bottom, equal top plus bottom over bottom. Do the same thing twice. D over I equal E over J, so we have E over D that's going this way. So we're going to do the same thing without crisscrossing. So we'd have J over I. Do the same thing twice without crisscrossing. This went from E to D, so we're going to go back from J to I. Okay? All right, now we're going to deal with some similar triangles. In similar triangles, corresponding angles are equal. Angle Q is going to be equal to angle Y because they're both in the middle. So whatever Y comes out to be, that's what Q is going to come out to be. We don't know Y yet, so we can't find Q yet. Okay? We know that angle P is equal to angle X because they're both first, and so if P is 60, then X is 60 because they were both named first. We now have two angles of this triangle over here, and we know that the sum of the angles of a triangle is 180. So if we were to add the 80 plus 60, we'd get 140. 180 minus 140 is 40, so that leaves 40 degrees for angle Y. Angle Q is equal to angle Y, so angle Q is also equal to 40. So we've got angle Q equal 40 degrees. Now, the sum of the angles of a triangle is 180, so this is going to end up being 80 since 40 plus 60 is 100 there. And so we have that angle R is equal 80 degrees by the sum of the angles of a triangle is 180. We now have that all three angles of one equal all three angles of another, so these are obviously similar by angle-angle similarity. If they're similar, then the sides are in proportion, but we would want to be able to name that proportion. Actually, I'm not sure why I said they're similar by angle-angle similarity. It gave us that they were similar. I'm recording at night, and it's been a very busy day, so I think I might be a little bit tired. But anyway, we didn't need to conclude they were similar by angle-angle because we were given that they were similar, and that's the information that we were using to know that this angle of this one equals that angle of that one. Okay. So XA, we want to find XA. Well, let's go ahead and set up our extended proportion from the way they're named similar. First two letters PQ, first two letters XY. PQ of the one triangle would correspond to XY of the other. Last two letters QR would go to last two letters YA, so QR would correspond to YA. First and last letter PR would go to first and last letter XA, so PR goes to XA. We can go to the picture and pull the numbers out. PQ was 6. XY was 12. That gives us, if we reduce it, a scale of 1/2 or 2/1, depending on if we're scaling up or scaling down. Equal QR, which is 5, matching up with YA, which we don't know. Equal PR, which is 4, matching up with XA, which we don't know. So when we look for XA and YA, we would be using proportional reasoning there. We could use a proportion or dimensional analysis, and I think I'll do one of each. The scale factor of PQR, that's the little one, and you may have a hard time telling, but we do know that QP went to XY, so the 6 went to the 12. I should have probably drawn the second one bigger so you could see that. But we want to be able to logic our way through it instead of see our way through it. So sometimes I don't draw them to scale just so you can think about the logical part of it. We're going from little to big. If we're going from little to big, we use the big version of the scale rather than the little version of the scale. So we would say that it's 2 to 1 as we go from little triangle PQR to big triangle XYA. Now, we're going to find XA and YA. And on XA, I'm going to use a proportion. And on YA, I'm going to use dimensional analysis. If I'm trying to find XA, then I need the proportion with XA in it. Look at the top right-hand side of the screen. I just circled that. So 4 over XA is the proportion with XA in it. Now, that's side of the first over side of the second. That means we need to use our scale from first to second, since we said 4 over XA, little triangle to big. So we're going to go little to big. Okay, in a proportion, it has to be the same, little, big, little, big. We're going to cross multiply. 2 times 4 is 8. XA times 1 is XA, and so XA equal 8. Let's find YA using dimensional analysis. If we want to find YA, we're going to start with its partner. Now, YA's partner, if you look at the top right-hand side, is 5. And then we're going to multiply by the scale. Now, the 5 is a side of the little, and YA is a side of the big. And so we're going from little to big, and so we're going to scale up. And so we use the big version of the scale factor 2 over 1, and we get that YA is 10. Any questions on that section? Okay. The next section says name the similar triangles and tell why they are similar. If they are not similar, say so. We'll put no conclusion or not similar. The 3 ways to prove that 2 triangles are similar, recall, is angle. That means all of the angles of one equal all of the angles of another. Side angle side means that an angle of one triangle is equal to an angle of another, and the sides that form those angles are in proportion. And then side, 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 which means that all 3 sets of sides are proportional, meaning small over small equal medium over medium equal large over large. So let's see what we've got. In the first triangle, we obviously see quickly that vertical angles are equal. We've got the arrow in the middle of both of those lines, which means those are parallel. If those are parallel, then alternate interior angles are equal. Angle A and angle E make a Z, so they're equal. Angle B and D would be equal because they're also alternate interior. All of the angles of one are equal to all of the angles of another, so they're similar by angle-angle similarity. Now, A is equal to E because they're alternate interior angles, and the lines were parallel. So angle A goes first with E in first. Angle B is alternate interior to D, so they were equal. B's in the middle, so D goes in the middle. The C's were vertical angles that were equal, and so the C goes with the C. Any questions on number 15? Number 16, we have an angle of one triangle is equal to an angle of the other. That's all we know about the angles. We don't have two angles. We've only got one angle, so all we can try is side angle side. So we look at the sides that form the angles. The sides that form this angle are 6 and 8. The sides that form this angle are 6 and 4. We want to see if they're in proportion. And so we put small over small equal large over large. Small of this is 6. Small of that is 4. We're going to put small 6 over small 4. Large of this is 8, and large of that is 6, so we put large 8 over large 6. Now we can divide the first set by 2, and it'll reduce to 3 over 2. We can divide the second set by 2, and it'll reduce to 4 over 3. Those are not equal, therefore they are not similar. We are not going to put no conclusion. We can reach a conclusion. Our conclusion is that those are not similar because the sides are not proportional. Okay? We don't know any angles on number 17. All we know are sides. And so we have to check for side, side, side. And so what we're going to do is check with the smalls, mediums, and larges and see if they're proportional. So we're going to put small over small, medium over medium, and large over large. The small of this triangle is 3. The small of the big triangle is 6. So we're going to put small 3 to small 6. The medium of the little triangle is 6. See, that's the small of the big one and the medium of the little one. See that? The medium of the big one is 12, and so we have medium 6, medium 12. The large of the right one is 8. The large of the left one is 16, so we put small over small, medium over medium, and large over large. The small, the BC was the small of the triangle on the left, and it was the medium of the triangle on the right. 3/6 reduces to a half. 6/12 reduces to a half. 8/16 reduces to a half. They're equal, so the sides are in proportion, so they're similar by side, side, side. Now we got to get the angles right. How do you do that? Well, A is what? Well, it's opposite the medium 6. So we look, it's opposite the small 6 of the triangle on the left. So we look opposite the small of the triangle on the right, and it's B. So A of the one on the left is equal to B of the one on the right because they were both opposite the smalls. Now B of the one on the left is opposite the medium size side. So we look opposite the medium size of the one on the left. Opposite it is X, and so B goes with X. C of the one on the right was opposite the largest side. It's also the opposite the largest side of the one. C's opposite the largest side of the one on the left. It's also opposite the largest side of the one on the right. So the C goes with the C. Any questions on number 17? Number 18, we have parallel lines. If the lines are parallel, then corresponding angles are equal. This angle at A and angle H are corresponding angles. Since those lines are parallel, we can say that they're equal. This angle at C and angle I are corresponding. Since the lines are parallel, we can say that they're equal. And angle B of the triangle on the top is the same angle as angle B of the triangle on the bottom. So we can say that angle B is equal to angle B. So we have it that all of the angles of one are equal to all of the angles of another. So we say that they are similar by angle-angle similarity. Now angle A, as you can see in blue, is equal to angle H because they were corresponding angles. They're equal because the lines are parallel. So we can say that A and H are equal. B was the same as B. It's equal to itself by reflexive. The C of the triangle on the top was equal to I of the triangle on the bottom. You can see in green that they make a backwards upside down F, and they're corresponding. They're in corresponding positions relative to the two lines. That's the formal definition. The C is in the top right position, and the I is in the top right position. I'm sorry, top left position of the of that line. Okay. Number 19. What we have is the bisector of an angle. We have a ray that bisects an angle. A ray that bisects an angle of a triangle divides its side into two segments proportional to the other two sides. Now when we set up that proportion, we're just going to not crisscross, and so the pieces of that side that was hit by the angle bisector are proportional to the other two sides of the triangle. And again, understanding that proportionality, we're going to set up a proportion such that we go the same way twice without crisscrossing. So we're going to say 4.3 over 6.7 piece over piece is equal to 10.4 over x side over side. And then we're going to cross multiply. So we get 4.3x is equal to 6.7 times 10.4. We're going to do that in the calculator. 6.7 times 10.4. We get 69.68. 69.68. And then we undo multiplication by division. So we have 69.68 divided 4.3. Which is 16.2 and a whole lot of stuff. 16.2 and a whole lot of stuff.